Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start the next topic in the series of chemical properties of carboxylic acid. So without wasting any more time, let's proceed further, and that includes the topics. So this includes the topic reaction involving COOH group as a whole. See, what is happening exactly over here is that your carboxylic acids and their salt, they undergo a number of reactions which involve either the elimination or decomposition of your carboxyl group, this group. Okay. Some of these reactions are discussed below like this. The first one being decomposition or decarboxylation reaction, which involve the removal of your carboxyl group, and second one is your reduction. So let's proceed further. In the decomposition or decarboxylation reaction, we are going to see four different methods of decarboxylation. The first one being chemical decarboxylation, second one is your electrolytic decarboxylation, that is coal based electrolysis reaction. Third one is your decarboxylation of silver salts of carboxylic acids in the presence of bromine, that is Hunts-Dicker reaction. And fourth one is your decomposition of calcium salts of fatty acid. So we'll be discussing all the four reactions one by one. So taking up the first reaction, that is chemical decarboxylation reaction. See, what is happening over here is that the sodium salt of your carboxylic acid when distilled with soda lime क्या है आपका NaOH plus CaO, और ये आपका किस प्रोपोर्शन में यूज होता है 3:1. ओके, एंड CaO इसका काम क्या होता है आपका टू एब्जॉर्ब जो आपकी कार्बन डाइऑक्साइड गैस रिलीज होगी यहाँ पे बाय द रिमूवल ऑफ योर COO कार्बोक्सिल ग्रुप, क्या होगा, इट विल अंडरगो योर डीकार्बोक्सिलेशन, मतलब रिमूवल ऑफ योर कार्बन डाइऑक्साइड, उसको एब्जॉर्ब करने का काम होगा आपका कैल्शियम ऑक्साइड का, and this will ultimately result in the formation of your product alkanes. Okay, like this. So over here you can see that the sodium salt of your this carboxylic acid RCOONA is reacting with your soda lime NaOH plus calcium oxide at temperature 630 Kelvin, giving you your alkane and sodium carbonate, and from where you can remove your carbon dioxide as well. So that is one way. Okay, and over here you can see the simplest mechanism as well. What is happening exactly? See, one thing you should keep in mind, that among C single bond O negative and C double bond O, the bond strength of C double bond O is more. So this will try to acquire this particular state. Understand? ओके, सो ऑक्सीजन अपना यहाँ से इलेक्ट्रॉन डोनेट कर देगा इस C सिंगल बॉन्ड O को, रिजल्टिंग इन द फॉर्मेशन ऑफ C डबल बॉन्ड O, एंड यहाँ से आपका क्या होगा, टेकिंग अप वन इलेक्ट्रॉन फ्रॉम दिस पर्टिकुलर बॉन्ड, आपका कार्बोनाइन बन जाएगा R नेगेटिव. ओके, and this carbanion will interact with your sodium Na positive and result in this particular structure. Okay, so that is one thing, and आपकी कार्बन डाइऑक्साइड यहाँ पे निकल गई. Now this carbanion intermediate will be reacting with your hydronium ion, giving you your alkane and sodium hydroxide. So this is the simplest mechanism by far. Okay, and the more you can write this mechanism in most simplest manner like this. What is happening exactly, you can see in this particular slide, that your carboxylic acid is reacting with your sodium hydroxide first of all, resulting in the formation of your sodium salt of carboxylic acid. Okay, and now it will be reacting with further to give you your alkane and carbon dioxide is released. That is the simplest manner you can mention this reaction, or otherwise you can follow the previous reaction only. Both of these are equally correct. Okay, and the simplest mechanism that you can show like this, that your this is your carboxylic acid and this one is your acidic hydrogen. Now from NaOH what you can get, OH negative, right? So this OH negative will be abstracting this particular proton from here, and it will result in the removal of your water and leaving this RCO negative over here. Now what is happening? Let me change the color of the pen. Okay. Now what is happening? I already told you that as compared to C single bond O negative, C double bond O is more stronger. Okay. So this will happen like this, and okay, this will not happen. And what will happen in the next step is your R negative carbanion intermediate is removed, which upon hydrolysis will be giving your your required product. So that is the simplest mechanism you can show. Correct. And proceeding further, that is our next topic, which include the effect of substituents on this particular chemical decarboxylation. चलिए अब देखते हैं यहाँ पे क्या होता है. See, since the formation of your carbanion or any organosodium compound is the key step, राइट. मैंने आपको पहले ही बता दिया कि दिस इज द मोस्ट इंपॉर्टेंट स्टेप ऑफ दैट इज द फॉर्मेशन ऑफ योर कार्बोनाइन ओवर हियर. ओके, सो होगा क्या कि कोई भी फैक्टर जो आपके कार्बोनाइन की स्टेबिलिटी को इंक्रीज करेगा वो ओवरऑल डीकार्बोक्सिलेशन के रेट को इंक्रीज करेगा. So any factor which tends to increase the stability of your carbanion will be ultimately increasing the rate of decarboxylation. Correct? So that is one thing to keep in mind. So ultimately what is happening? Carboxylic acid which contain electron withdrawing groups such as NO2, COH, COCH3 at its beta position just like this. Any carboxylic acid which at beta position will be carrying any of the electron withdrawing group will be increasing the rate of decarboxylation like this. Okay, will readily undergo decarboxylation on heating through 6-membered cyclic transition state like this. So यहाँ से आपका कार्बन डाइऑक्साइड निकल जाएगा. You can see like this. How? कैसे निकलेगा? See over here you can see the formation of the hydrogen bond between this heteroatom oxygen and hydrogen. See what is exactly happening over here is there is transference of electron from this C double bond O to this H bond, and it leads to the formation of your OH like this. Over here you can see, let me show you. Yes, over here you can see. So this OH is formed now. Now what is happening in the next step is your removal of carbon dioxide. It can occur like this. Your C double bond O will be formed by accepting the electron from this particular bond, and this electron will be transformed to the bond C single bond O, and it leads to the formation of CO2, which is removed after that. Okay, after then what is happening is this particular bond electron will be shifted to this CH2 double bond C. Okay, and it leads to the formation of this complete structure like this, which upon tautomerism will be giving you your required product. Okay, so this is how you can explain this particular effect of substituent on your decarboxylation. So some other example you can see. This is the example of your gem dicarboxylic acid, that is your malonic acid. Now what is gem dicarboxylic acid? Any compound in which two carboxyl group are readily attached to the same carbon atom will be showing your decarboxylation upon heating. Okay, so this is alpha. You can show beta over here also or over here also. Both will be carrying your COH group, that is electron withdrawing group. So what is happening? आप कहीं से भी CO2 का removal दिखा दो, प्रोटॉन ट्रांसफर दिखा दीजिए, रेडली आपके पास ये रिक्वायर्ड प्रोडक्ट आपका बन जाएगा. सिमिलरली आप बाकी एग्जांपल्स भी देख सकते हो. One example is of your 2,4,6 trinitrobenzoic acid, which upon heating will be giving you your this particular 1,3,5 trinitrobenzene by removal of this particular CO2. Okay, and this is another example you can see where at your alpha position, beta position what is present, C double bond O. So over here you can see, yeah, this is your beta position. Okay, so on beta position another your electron withdrawing group is present. So what is happening? Ultimately removal of your CO2. So that is how you can mention your chemical decarboxylation, and it is quite easy to remember. The next is your electrolytic decarboxylation, also known as coal-based electrolysis. Okay, quite simplest it is. So what is happening exactly over here? This is the main reaction that you can see, where 2 moles of your sodium salt of carboxylic acid will be dissociating to give you your carbanion, that is RCO negative, 2 moles of it, and 2 moles of your cation, Na positive. Okay, similarly your water will get dissociated in a same manner, and your carbanion will be shifting to your anode, and your cations will be shifting to your your anions will be shifting to your anodes, and your cations will be shifting to your cathode side. Okay, and what is now happening? Your at anode, if this will occur, that 2 electrons are removed from this particular RCO negative carbanion, what is happening from this particular anion? What is happening? It leads to the formation of this RCOO, 2RCO, which is quite unstable structure. Okay, and from it, if you ultimately can remove your CO2, and you will get this particular alkane. Okay, this is happening at your anode, and at cathode what is occurring? Both your sodium plus and your H positive cation from your water, they are present. But see, this H positive are preferentially they are discharged. Why? Because इसका ionization potential आपके सोडियम के कंपैरिजन में कम है, which is why वो preferentially आपका discharge हो जाएगा as hydrogen gas. Okay, so that is one thing. So overall reaction आपके पास क्या बन जाएगी? RCONA, that is sodium carboxylate, will be reacting with your water. Upon high electrolysis will be giving you your alkane. Carbon dioxide is released, hydrogen gas is released, and NaOH is released. So that is one thing. That is the simplest method of decarboxylation, that is your col-based electrolysis. So this we have explained by taking the example of your acetate, sodium acetate. So I request you to see this the previous slide first of all, that is a general mechanism of your col-based electrolysis, and ultimately you will end up understanding this as well. So this is quite simple. Okay. So proceeding further to the third part, which includes the decarboxylation of silver salt of carboxylic acid in the presence of bromine. See, what is happening over here is the silver salt of your carboxylic acid on treatment with your bromine. On refluxing with CCl4, it will be giving you your alkyl as well as aryl bromide like this. This one is your alkyl bromide. This one is your aryl bromide. The process will remain same. Silver salt of your respective carboxylic acid will be reacting with bromine, and on refluxing with CCl4 will be giving you your alkyl or aryl benzene or bromide. Sorry, not benzene, alkyl and aryl bromides on removal of your carbon dioxide and silver bromide. Okay. So this alkyl and aryl bromide which is formed, it contain one carbon atom lesser than your parent acid. Okay. See, parent acid में यहाँ पे आपके पास कितने थे? 2 कार्बन एटम थे. यहाँ पे कितना है? 1 है. यहाँ पे भी आपके पास कितने हैं? 7. यहाँ पे कितने होंगे? 6 होंगे आपके पास. Okay. So that is something to remember. Okay. So over here you can see the general mechanism of your this particular Hunt-Stecker reaction. Okay, this is also known as Hunt-Stecker reaction. So in your exam, such kind of reactions are directly asked mostly. So you should keep this thing in your mind. Okay, and this is the mechanism. Over here you can see the silver salt of your carboxylic acid. What is happening? In this particular silver salt, this will be reacting with your bromine and will be giving you your this structure, that is RCOOBr, and silver bromide is released. Now in the second step is occurring, this is your actually free radical mechanism. Okay, this is your free radical mechanism. In the second step is occurring your initiation. Alright, so what is happening? Open it up. RCOBr. Now what is happening? This bond is comprising of 2 electrons. So यहाँ पे आपके पास एक इलेक्ट्रॉन यहाँ आ जाएगा और एक यहाँ आ जाएगा. So which is why this will be carrying your this radical and bromine will be carrying one radical as well. Okay, so this is one thing, bromine radical and this particular acid radical is released. So now in this step third and fourth will be occurring propagation. What is happening? In this particular step, what is occurring? This will occur like this. It will be taking one radical with itself and one radical will be going over there to form double bond. So it will result in the releasing of your carbon dioxide like this. Okay, so that is the structure of your carbon dioxide, and R radical is released. Now in the step 4, what is happening? It is again reacting with this particular RCOOBr and it results in the formation of RBr and RCOO radical. So this is how the mechanism of your Hunt-Stecker reaction occurs. It is quite simpler to follow, and I hope you have understood all this very well. So the last decomposition method includes the decomposition of calcium salts of fatty acid. In the first step, you can see the dry distillation of your calcium formate, that is this one. What is happening over here is it leads to the formation of your formaldehyde ultimately. Correct? Understanding? So this is how it is occurring, and it leads to the removal of your calcium carbonate. That is one thing that is going to occur. So you can see the formation of your formaldehyde from calcium formate. That is quite simpler. This carbon dioxide is released and CaCO3 is released as such. So as such, so which leads to the formation of your formaldehyde. Quite simpler, right? So in the second step, what is occurring? Dry distillation of calcium salt of another acid. It leads to the formation of formic acid, which it leads to the formation of your acetone, not your formic acid. Okay, so how it is occurring, that over here you can see that there are two alkyl group attached to this particular calcium carboxylate, and it leads to the formation of after the removal of your CaCO3, it leads to the formation of your RCRO. Okay, quite simpler, right? So you can follow the rest of the example as well. So this is all about the decomposition of calcium salt of fatty acid, and I'll stop my video over here only. I request you to see the previous videos as well, and the next part will be taken up in the next video. So yeah, thank you.